on, guys? It's Alexander here. I have posting this video. It's kind of just a random video that I decided I wanted to post because I haven't posted a lot of videos recently. So I thought I'd show this prototype for a sequential shifter I wanted to make that I could use for Forza Motorsport. Because I didn't want to have to use my paddle shifters for cars that didn't actually have them because that like is not realistic. So yeah, so I haven't actually worked on this in a while since I haven't had a lot of time, so I'm gonna have actually forgot some of the things that I did. So just bear with me if I need to take a second to think. Um, but yeah, so basically, I'll show you guys the first sketch. So this is the motion study I use for the lever and spring mechanism, or I mean the cog mechanism. I have a it's based. This is based off the I forget the name of it, but it's like one that you can buy. And there's a video that I'll put a link in the description for that you can see. But yeah, so basically, it consists of it's basically gonna sit in a box, and that has a cog, and then the lever which you pull that is attached to this claw right here. So if I don't even remember where my constraints are. Hold on. Delete this horizontal constraint. Yeah. So basically, this is the arms. You pull it, and then there are two stops. So this is the high position. So when you upshift, you pull back because when the weight when you're under acceleration, the weight of the car centers to the back. So you want to shift. You want to pull to the direction of the weight. So you pull back for upshift. That thing stops it. That circle up there. That's just going to be like a peg that is screwed into both sides of the plates, or screwed into both plates, and downshift you hit that one. So then this is also just a test to see, because this cog's supposed to move. This is locked in this position right now, if I just remember which constraint I put to actually lock it, which I think is this one. Yeah, so basically there'd be a spring that's holding in position that you'll see later. So if you apply the hinge constraint, you'll see this is just a test, like because I wanted to fit about 3 pegs into the claw, and the pegs would basically just be like 10 millimeter stainless steel dowels that will be press fit. So when you pull up, this will pull the cog up, and it basically needs to do it so that the peg ends up in the next position, so the spring locks it in. So if you see at the bottom where it's tangent, you pull up. I just made this to make sure nothing would like no lines would like intersect, so that everything would work. So you pull up, you'll see when you start it's in this position, and then when you pull up, then all the pegs are basically look the same, which means that it's in the next, which means it's moved 45 degrees so that the spring would lock in again. And it's basically the same thing for moves down. Also, this also makes sure that this also to see where the placement of the stoppers should be, because I need to make sure that you can't pull like too far, but also you can pull enough so that the spring locks into the next position. Yeah, so that's about it for that. So next I did this plate. It has this weird lining pattern. It doesn't really matter that much because it's not like it's under that much stress, so the ribs don't really matter. It's just to reduce the amount of filament used. So what the hell was that? I just heard like an explosion outside. I don't know if that's bad, if I should be concerned, but whatever. So basically, yeah, I've all just these holes is basically where I'm putting screws in. So these are the two stopper pegs that are also just 3D printed. Those are the holes are smaller because I'm gonna tap those, and then you'll just have like button heads or something that will screw them against the plate. So here is this cog I'm talking about. So when I'm talking about the spring, what I mean is that this part isn't fully fleshed out. I don't really remember where I stopped because it's been like a month since I worked on this. But basically, there's going to be a 3D printed part that kind of sticks out of this with like a dome end, and that will sit in with a spring that's basically pushed against the top. This should not be open. I don't really know why it is like that. I think I just forgot to change that, but I'll get to that later. So basically, that it would move up, it'd be pushed into it, and then once this moves another 45 degrees into the next like divot here, it would sink back down again, and then it locks this cog. So the reason we have that is so like you actually have like there's actually like a feeling to when you pull it that you actually like moving something, because obviously isn't physically attached to any kind of transmission. So this is just to give like kind of a heavy feeling of like when you shift. And then yeah, so then these are just like the outer pegs that connect the two plates. I don't have the second plate because that'll be in the assembly. Yeah, so then this is just a prototype, so I didn't really bother to put like bearings and stuff. So this is just kind of rotating on this other 3D printed piece. And then there's just a spacer here that spaces it off from the plate. So over here is a bit more complicated. So basically in order to get this to center, like after you pull back, in order to pull the lever to the upright position, there's a torsion spring. I forget how much force it is. It's a right wound spring. It is 12.86 inch-pounds. So basically that sits in, it's kind of hard to see, but I can, if I hide the not the lever shaft, the gear lever. Yeah. So basically, then let me hide the claw. Okay. So basically this is the imprint into the plate where one end of the spring would sit. If I, I have a sketch for it. Just, where is it? Hold on, give me a sec.
Where is this sketch, man? I didn't name my sketches. I kind of stopped naming them because they're kind of like annoying to keep doing them. Oh my god, where is it? Where is the sketch? I don't think that's it. Oh, here it is. I think I found it. Is it? No, it's extrude. Is this it? I think this is it. Oh, this is for the other side. Oh my god. Oh my, here it is. Okay.
This is the construction sketch for the spring, just based on the dimensions that McMaster-Carr gives me. So these construction lines are like what the actual spring is, or its dimensions are. And then yeah, so then these non-constructions are that's just to get with a bit of clearance. I think it's about 0.15 millimeter clearance on both sides. And then it kind of just sits in there, so one end just kind of sticks in to this cutout. And then on the other side is when we have the lever shaft. So if we, or not lever shaft, oh my god, where the heck is it? Gear lever, oh my god, it was right there. Okay, so if I hide the plate, oh yeah, so this is on the other side. So basically, the spring sits around this 3D printed part, and then it's basically, this is part of the shaft, but it's like shaved down here because the spring like can't fit around that shaft because it's too small. So it's rotating around the shaft, and then the other end sits in here and goes up into here. So that basically is what gives the lever spring. So it returns it to the position, to the vertical position when you're done. Yeah, so it's not done yet, but oh yeah, so so the claw parts. Basically, so how it like resets is that these wings here are slanted. So when you like tilt it upwards, actually, and I don't think I have an assembly of this here. That's fine. But basically the wings, what happens to so like imagine they're like little dowels sticking out of here. That'll be in the assembly. This part, the claw like pulls out and then goes over them when you reset. And then there's like going to be a spring goes around the shaft here that's on the other plate that lets it rise up and pull out. And then these slanted wings kind of like push it up when it moves over the dowels. So then, yeah, so here will be just a small peg just to keep it so it doesn't rotate, because there needs to be two points to prevent it from rotating around the shaft here. And then there's just like a pill cut out because it needs to like be longer since it's like rotating. It's like tilting upwards. So, and then also what allows it to rotate is basically just this little bit of clearance. It's enough. I have a motion study to test that. So it's which is the right one? Here it is, I think. So there's a total of 0.4 millimeter clearance between, like, this part is the shaft, and then this is the gap in the claw. This is the hole that it sits in. So this is basically just to test if that clearance is just enough to allow it to reach up high enough. So I don't know why I don't have a driven dimension here. I should probably put that in, but whatever. So basically, yeah, 12 millimeters is enough because the whole dowel is 10, but it sits in about 6 millimeters, I think. So it'll be enough to rise over and move in. It'll be easier to see if you watch the video that I link because it's kind of just based off that. But I didn't want to buy that. I just wanted to make this because it's a good project. So yeah, that's about it. It's not finished yet, but hopefully it will be. And then after I make the prototype, I have to figure out how to connect it with some kind of Arduino or Raspberry Pi or something, so then I can actually use it. But yeah, this is just to test like all the mechanical stuff. Yeah, I think this lighting pattern is pretty sick, to be honest. And the handle kind of just plugs into the top. Um, there's like a hole here, and then there's just gonna be through screws that go through. Because there's just like this part that sticks in, and then those you just put a through screw with like nuts on the other side. Yeah, so that's about it. Hope you enjoyed this video. Yeah, let me know what you think in the comments. Maybe I might, when I'm done, I might send the or might link the STLs in a Google Drive or something so you can print them for yourself. But yeah.